Hi everyone, Assalamualaikum. In this video, we will continue with example 5 under separable equation for first order ODE. Solve the separable differential equation 2 plus y squared times e to the power of negative x squared dy minus xy to the power of 4 dx equals to 0. This is first order ODE because we have dy dx here means first derivative. Right? And when we want to solve separable equation under first order ODE, first step, we need to separating variables x and y. Left hand side, we want to write fy dy, and right hand side, we want to write fx dx. Right? From the given question here, when we want to separate, we need to reverse the order of BODMAS. We recall back BODMAS. Okay? BODMAS is an acronym and it stands for bracket, order, division, multiplication, addition, and subtraction. If we want to solve a mathematical operation, we need to follow the order of BODMAS. Okay? But if you want to separate, we need to reverse the order. Means, we need to separate minus and plus first. After that, we separate multiplication and division. Then, we separate order, means exponent, and bracket. Right? Alright, so from BODMAS here, when we reverse the step here, so first, we need to separate plus or minus sign. So now we have minus sign. Okay? Alright, so when we separate, we can move negative x y to the power of 4 dx to right hand side. So after we move, we get this. 2 plus y squared times e to the power of negative x squared dy equals to positive xy to the power of 4 dx. Right? Right, after subtraction, we need to separate plus. But plus here is inside bracket. Okay? So we consider b here. Okay? So means that after minus here, we need to separate multiplication and division. Okay, so from here, now our goal, we want to write left hand side in terms of fy dy. So we need to move term containing x. Okay, and this is multiplication operation. Okay, alright, so from here, when we move e to the power of negative x squared to right hand side, we have this. Okay, we have over e to the power of negative x squared. Okay, and then we want to write y to left hand side. So we can move y to the power of 4 to left hand side. So we get over y to the power of 4. Right? Up to this point, we done separating variables x and y. Okay, because now from left hand side, we can see that we have only term containing y and dy. And there is no term containing x. And on the right hand side, we only have term containing x and dx and no more variable y. E here is not a variable, but e is a natural number, which is 2.718 something. Right? Right. Before we integrate, we can move e to the power of negative x squared. We move up here, okay, using the properties of indices. Okay, if we have over negative exponent, when we move up, we have positive exponent. Okay, so after we move up, we get this. We still have 2 plus y squared over y to the power of 4 dy on the left hand side, and then equals to x. Then we have e to the power of positive x squared using this formula. And then dx. Right? Right. After that, we can continue with step 2. Okay? Integrating both sides. Okay? From this step, we just put integration sign for both sides. Okay? Then we need to integrate left hand side and right hand side. Okay. So before we integrate, we can name as equation 1. Right? So it's easy to refer. Right? From the previous slide, we get this. And then we name as equation 1. Now we need to integrate one by one. We integrate left hand side and then we integrate right hand side. Alright? Alright. For left hand side, we can integrate using power rule. Okay? So integration of 2 plus y squared over y squared dy, before we integrate, we can separate. Okay? So we have integration of 2 over y to the power of 4 plus y squared over y to the power of 4. Okay? Then we can move up over y to the power of 4 using the properties of indices. So we get 2y to the power of negative 4. Okay? And then from y squared over y to the power of 4, we can simplify using the properties of indices. So when we move up y to the power of 4 here, we have minus 4. Okay? Then it's equals to integration of 2y to the power of negative 4 plus y to the power of negative 2 dy. Okay? From here, we have n not equals to negative 1. So we can integrate using power rule. Okay? So from here, when we integrate, we still have constant 2. Okay? And then when we integrate y to the power of negative 4 using power rule, so we get y to the power of negative 3 because negative 4 plus 1. Okay? And then over negative 3 because negative 4 plus 1. And then plus, when we integrate y to the power of negative 2, so we get y to the power of negative 1 over negative 1 using power rule. Alright? And then plus c. Then we can simplify 2 over negative 3 here. So we get negative 2 over 3. And we can move down y to the power of negative 3 using the properties of indices. So we get over y cubed. Right? And then plus and minus sign here, we get minus. And then we can move down y to the power of negative 1 using the properties of indices. So we get 1 over y to the power of positive 1. Okay, we just write y only. Alright? Alright, after that, we substitute into equation 1 for left hand side here. Alright? Then we integrate the function on the right hand side. Okay? We can integrate x e to the power of x squared dx using integration by u substitution. In this case, our u equals to x squared. Okay? After that, we need to find du over dx equals to 2x. Then we write dx as a subject, okay, which is du over 2x. Okay? So, integration of x e to the power of x squared dx equals to, we have x here and then e. We replace x squared equals to u. And we replace dx equals to du over 2x. Right? Then we can simplify x here and x in denominator here. Okay? And then at the same time, we can move out over 2 from integration sign. So we have constant half. And then integration of eu du. Right? So from here, we can integrate. Okay? With respect to u. So we have constant half. And then when we integrate eu du, the answer equals to eu plus c. And after that, we can replace u equals to x squared. So the answer when we integrate the function on the right hand side equals to half e to the power of x squared plus c. Right? After that, we can substitute into equation 1. Okay? Right. Then substitute left hand side and right hand side into equation 1. So we get the general solution. Okay? After we substitute, we get this. Yeah? After we integrate 2 plus y squared over y to the power of 4 dy, we get negative 2 over 3 y cubed minus 1 over y. And that equals to, after we integrate the function on the right hand side, we get half e to the power of x squared plus c. Alright? This is the final answer because there is no initial condition here, so we no need to find the value of c. Right? So we just stop our solution here. Okay? From the previous slide, after we solve separable equation, then we get the final answer, negative 2 over 3 y cubed minus 1 over y equals to half e to the power of x squared plus c. Right? Is my answer correct or wrong maybe? We can check the final answer. Okay? We can check whether this answer is correct or wrong. But how? From the final answer here, we can differentiate back. Okay? And then we can substitute into this equation. Alright? So from here, to differentiate, first we need to move y cubed over y cubed here. We move up using the properties of indices. So we get times y to the power of negative 3. And then over y here, we move up using the properties of indices. So we get y to the power of 1. Okay? Then we can differentiate implicitly with respect to x. Okay? Because we want dy over dx. Right? So from here, after we differentiate, okay, we differentiate one by one. Because in between we have minus sign and plus sign. Okay? So after we differentiate, so we get this. Okay? Right. Let me discuss one by one. Okay? To differentiate negative 2 over 3, y to the power of negative 3. Okay, first, we still have constant negative 2 over 3 in front here. Okay? Then, we differentiate y to the power of negative 3 using power rule. So, we move negative 3 to front here. Then, we have y and then negative 3 minus 1. When we differentiate, we need to minus 1 from the original power. So, we get negative 4. And after that, we differentiate y with respect to x. So, we get dy over dx. Right? And then, we differentiate minus y to the power of negative 1. So, using power rule, we move negative 1 to front here. So, we get negative times negative 1 equals to positive 1. And then y to the power of negative 1 minus 1. So, we get to the power of negative 2 here. And after that, we differentiate y with respect to x. So, we get dy over dx. Alright? When we have term containing y, we must have dy over dx. Alright? Because we differentiate with respect to x. Right? And then, when we differentiate half e to the power of x squared, we still have constant half in front here. And then, we differentiate e to the power of x squared using exponential rule. So, first, we just copy e to the power of x squared. And then, times, we differentiate the exponent. Means we differentiate x squared. So, we get 2x. Okay? And then, plus, then we differentiate constant. When we differentiate any constant, the answer equals to 0. Right? Right. At this point, we done differentiate. Right? After that, we can simplify. 3 here and 3 in denominator. And we can also simplify 2 here and 2 in denominator here. Okay? And after we simplify, we get this. Okay? Negative times negative equals to positive. And then 2y to the power of negative 4 dy over dx. And then plus y to the power of negative 2 dy over dx equals to, we move x in front here. So we get x e to the power of x squared. And then plus 0. No need to write. Right? Now, we want to write dy over dx as a subject because we have two terms containing dy over dx here. Okay? So we need to write single dy over dx as a subject. Right? From the previous slide, we get this. We have two terms containing dy over dx. So to write dy over dx as a subject, we need to factorize dy over dx. So in bracket, we have 2y to the power of negative 4 plus y to the power of negative 2 and then equals to xe to the power of x squared. Okay. Then we can write dy over dx times, in bracket, we write 2y to the power of negative 4 into the form of 2 over y to the power of 4 using the properties of indices. And then plus, we write y to the power of negative 2 into the form of y over y squared using the properties of indices. Okay, and then equals to x e to the power of x squared. Okay, and then from here, we can standardize the denominator. Okay, to simplify this fraction. So, to standardize the denominator, we need to write y squared here into the form of y to the power of 4. Okay, to write y squared here into the form of y to the power of 4, we need to multiply 1 over y squared by y squared over y squared, because y squared over y squared equals to 1. So when we multiply, it doesn't change the original value, right? So after that, we have dy over dx times 2 over y to the power of 4 plus 1 times y squared equals to y squared times y squared equals to y to the power of 4, right? And then equals to x e to the power of x squared, right? Now we have same denominator, so we can combine the denominator. We can write dy over dx and then in bracket 2 plus y squared in numerator and then over y to the power of 4. Okay, and then equals to x e to the power of x squared. Okay, from here, to write dy over dx as a subject, we need to move this fraction to right hand side. Okay, and after we move to right hand side, so we get dy over dx as a subject equals to x e to the power of x squared times, we need to exchange the numerator and denominator. So we get y to the power of 4 in numerator and 2 plus y squared in denominator. Okay. So after that, we multiply x e to the power of x squared by y to the power of 4 only, because x e to the power of x squared here means over 1. So means that x e to the power of x squared times 1 times y to the power of 4 and then over 1 here times 2 plus y squared. Okay, so after we multiply and we rearrange, so we get dy over dx equals to x y to the power of 4 e to the power of x squared and then over 2 plus y squared. Right, now we write dy over dx as a subject. Right, so this is our dy over dx. Okay. From the previous slide, we get dy over dx equals to x y to the power of 4 e to the power of x squared over 2 plus y squared. Okay. From the given question here, we have dy and dx. Okay. Alright, so from here, we can write dy as a subject. Okay. So we can write dy equals to, we move dx to right hand side, so we get xy to the power of 4 e to the power of x squared times dx over 2 plus y squared. Okay. So dy here, we can substitute into dy in the given question here. Okay, so now we substitute dy into left-hand side. Okay, to prove that left-hand side equals to right-hand side. Okay, if we success prove that left-hand side equals to right-hand side, means this answer is correct. Okay, so from left-hand side here, we have 2 plus y squared times e to the power of negative x squared dy minus x to the power minus x y to the power of 4 dx equals to 2 plus y squared times e to the power of negative x squared, and then we replace dy equals to x y to the power of 4 e to the power of x squared dx over 2 plus y squared, and the operation here is multiplication. Okay, and then minus x y to the power of 4 dx. Right? Right, since we have multiplication operation here, so we can simplify 2 plus y squared here and 2 plus y squared in denominator. Okay, so after we simplify and we rearrange, so we get x y to the power of 4 e to the power of x squared times e to the power of negative x squared dx. Okay, no more over 2 plus y squared because we simplify with the other 2 plus y squared here. Okay, and then minus x y to the power of 4 dx. Okay, and from here we have e to the power of x squared times e to the power of negative x squared. Okay, so from the properties of indices, if we have index with same base, okay, and the operation is multiplication, so we can add the exponent. Okay, so from here we can write x y to the power of 4, and then we can write base e here. Okay, and then x squared plus, okay, plus and minus here, so we get minus, and then x squared. Okay, and then dx minus x y to the power of 4 dx. Okay, so we get this, okay, using this formula. Okay, and after that we have x y to the power of 4, and then e x squared minus x squared equals to 0, and then dx minus x y to the power of 4 dx. Okay, e to the power of 0 equals to 1. Okay, from properties of indices, any value to the power of 0 equals to 1. So we get x y to the power of 4 dx. Okay, and then minus x y to the power of 4 dx. Okay, now we have same term, and in between is subtraction. Okay, so we get 0. Okay, so from here, from left hand side here, the answer equals to 0 after we substitute dy into left-hand side. Okay? So when we compare, the function on the left-hand side equals to the function on the right-hand side. Okay? Means that this answer is correct. Okay? So that's the way how you check the final answer. Is it the final answer is correct or wrong? Alright? Got it? We have discussed 5 examples from method 1 to solve first order ODE, which is separable equation. Coming up next, we will discuss method 2 to solve the first order differential equation, which is homogeneous equation. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.